In this tutorial, we have a reactor with one inlet and one outlet. Feed stream enters at a temperature of 50 degrees Celsius, a pressure of 20 kilopascals, and a molar flow rate of 100 kmol per hour. This stream contains 50% ketene and 50% acetic acid. This reactor is adiabatic. In this reactor, ketene and acetic acid react to form acetic anhydride. The product stream exits from top, whose flow rate and composition needs to be determined. Now, we will model this whole process flow diagram in Aspen HYSYS. We will be using equilibrium reactor model for this purpose. The equilibrium reactor is used to simulate chemical reactions that reach equilibrium conditions. The outlet streams from the reactor are assumed to be in equilibrium with respect to both chemical reactions and physical phase conditions. Any number of equilibrium reactions can be included in the reaction set connected to the equilibrium reactor. These reactions can occur simultaneously or in a sequential manner within the reactor model. The software calculates the chemical activity of each component using mixture and pure component fugacity. The reactor model does not require perfect mixing of components for equilibrium calculations. For each reaction, the model shows important parameters such as base component, conversion, equilibrium constant, and reaction extent. Conversion, equilibrium constant, and reaction extent are automatically calculated from the equilibrium reaction data. Open Aspen HYSYS software. Click on New button. Click Add to open the component list. Add pure components by typing their names in the search bar and pressing Enter. Enter ketene, acetic acid, and acetic anhydride. Go to Fluid Package, click Add, scroll through the list, and select PRSV as the property package. In the navigation pane, open the Reactions tab and click Add to create a new reaction set. Click Add Reaction. Create an equilibrium reaction, then close the window. Double-click on Reaction 1 to add its details. First, enter all the participating reaction components, and then define their stoichiometric coefficients. Define coefficients of reactants with negative sign, and products with positive sign. Status bar turned green, indicating that the reaction is defined. Note that we have not assigned the conversion of the equilibrium reaction, because conversion depends on equilibrium constant source. Click KEQ tab and see the source of the equilibrium constant. In this example, the equilibrium constant depends on Gibbs free energy, which is taken from the database of components that are saved in software. The equilibrium constant value can be estimated by providing the required data in different sources. Now, click on Add to FP button to attach reaction set to fluid package. Now, proceed to the simulation environment and begin developing the process flow diagram. Add a material stream by dragging the blue arrow from the object palette. Double-click the stream 1 to enter its properties and name it Feed. Set the temperature to 50 degrees Celsius, the pressure to 20 kPa, and molar flow rate to 100 kilograms mole per hour. Next, open the Composition tab and enter the mole fraction of ketene and acetic acid as 0.5. After defining the composition, click OK and close the feed stream window. Search for equilibrium reactor model from object palette and drag it on PFD. Double-click the reactor icon to open its window. In the inlet field, select feed stream. In vapor outlet field, enter vapor to create a new material stream. Although the liquid product from this reactor will be 0, you must still assign a name to the stream. In liquid outlet field, enter liquid to create a new material stream. On parameters page, since there is no data about pressure and the simulator assumes 0, let it be the default value. On the details page of the Reactions tab, select Set 1 as the reaction set. This selection automatically connects the proper reactions to the reactor. Green status bar confirms that the reactor is fully defined. Click the results page to see the conversion of reaction and the value of equilibrium constant. The conversion of base component, which is ketene in this case, is 50%. Equilibrium constant is 15.44 and reaction extent is 25.16. Select Reaction Balance Radio button. The amount of each component's inlet, outlet, consumption, and generation can be monitored here. At the inlet, 50 moles of both reactants are present, while acetic anhydride is 0. After the reaction, reactants convert into product at 50% conversion of ketene. Resultantly, 25.16 moles of acetic anhydride are formed. Select Worksheet tab. The temperature of product stream is 228.5 degrees Celsius. Go to the composition page and analyze the composition in vapor stream.